What's going on, everybody? Today we're going to learn how to have our camera orbit around our player. So, like you would see in a normal video game, so you can look around, up and down. Awesome. And we can move around too. All right, so let's get started. Let's get started. So, the first thing that we want to do, yes, so follow along with me. And the first thing that we're going to be doing, we want to put our camera inside of a parent object, and we're going to talk about that later. And let's just call it, instead of game object, let's call it cam follow or cam parent. Cool. And I want to nest the camera parents inside of the player object. Uh, and I'm doing this because we're going to have the camera orbit around the player, and I want to use, so that means we're going to use the player as like our pivot point, so as to always have access to that, or to easily have access to that pivot point, and that's the cam parents within the player. And then I'm going to put the cam parents to have the same position as the player. And then we're going to have the camera be where we want it to be. So before we do that, let's orient our camera so that it's looking at the player, if it's not already. And let's just play and let's see what happens. So you'll be seeing that, the camera is following the player around. And we talked about that on the last project, and that's because cam parents, along with main camera, are children, or they're nested within player one. So that means the transform component of cam parents is taking lead from of player one. So its position is in reference to player one. So player one position is changing, while the cam parent position uh, needs to stay the same in reference to player one. So that's why it moves along with it. Yeah. Okay, cool. So just to make it how we want to do it, we're going to have the camera rotate around cam parent. That's kind of how it's going to work. But we're going to have cam parent have the same position as player one. So if you select cam parent, go to transform components and click these three dots. You can click reset or just set these to 0. I'm going to click reset though. And you'll see now that cam parent is located right where the player is. Cool. And let's look at main camera. Let's see where that is. Okay, so now main camera is right where cam parent is. So I'm gonna move the main camera back and up so it can be looking at the player. You can look at the game tab to see kind of where it is, or you can look at this mini window here to also see. Okay, cool. So I'm gonna keep it like that, and let's just do this again so we can see. So it acts the same still. Awesome. And let's see. Okay, cool. So now what? Now let's actually get our camera orbiting around the player. So let's create a new script. I already have one, but let's create a new one for this. Create C# script, and let's call it camera orbits. So I called it camera orbit. Okay, so camera orbits. Let's see. So we're going to be using the mouse inputs to move the camera around the player and up and down. So let's create some variables to help with that. Let's see. So let's create a vector 2 variable. So similar to vector 3, except this one just has x and y components. And let's call it local rotes for short for rotation. And here are the other variables that we're going to need. So mouse speed that controls like the sensitivity of the orbit. So like how much the orbit moves for like every movement of the mouse, or how much the camera moves for every movement of the mouse. And then we have orbit dampen, so that changes this a variable that'll change kind of like the speed of the orbit. Yeah, so for every mouse movement, how fast will the camera move to its newly assigned position, something like that. And we have something new in front. It's called serialized field. So serialized field basically means that you'll see the field in the inspector, and you can have make changes to the field's value or the variable's value in the inspector. Here's some more information about it from the documentation page. Um, Force Unity to serialize a private field. Nice, nice. So let's go back. So I guess normally Unity will show. Yeah, normally Unity will show like a public field. Like say I make something public, um, floats num equals 3. So let's say I do that. I go back to Unity. Give it a second. Right, so back in Unity. And let's add the script to our game object. So cam parent. Another way to add a script is to go to add component. So to click the game object, then to click the add components button and type in the file name, and it'll show you it right here with spaces for each word. Yeah. Okay, cool. And yeah, so we see all our fields right here. So that's what I was talking about. So Am I lagging? So awesome. So let's look at. So you see I have public floats, and you can see that in the inspector within the script component camera orbit. But you can also see these variables. So that's basically what this does. So if I made it private, those fields would still be there. Cool, and you see they're still there. So that's what this keyword is for. So more you know, and we'll move on. So we want these two things there. I'm gonna remove this. And now the next thing that we'll do is get the input for the mouse. And we'll be grabbing that from the input. Oh man, I hope you can see this. So I just put in this, so this is us grabbing the mouse input and putting it into the vector components X and Y. And you see I made it, yeah, so let's start from our changes. So we have the local rote vector 2, and I'm setting it equal to vector 2.0. So basically I'm setting it equal to 0, 0. Just giving it an initial value. And then here I'm getting the value from the mouse, multiplying it by mouse speed, and then I'm adding it to uh, let's say the past value of the mouse or the current value of the mouse. Yeah, and then I'm putting it back into local rote X. So I'm getting the current value of local rote X, and then I'm adding it to the input from the mouse X, or the X axis for the mouse, multiplying it by mouse speed. So this way, every time we move the mouse, this value is going to increment by this. So this is, yeah, that makes sense, right? And same thing for the Y component. So it's doing the same thing, except now it's looking at the mouse Y. And just as a reminder, um, this is where, so these input values that we're talking about, you can see them defined like I showed you before. If you go to edit, project settings, on the left tab, on the left hand side, you want to select input manager. And you'll go down, open them axes, and you can see all the axes that are defined. If you want to define a new one, you just increase the size, and then you'll get a chance to define a new one. And here is where mouse X is defined. Here's where mouse Y is defined. Here's the name, gravity. So this is um, if you want it to fall back to 0, like the value to go up and then fall down to 0 when it's not active. Sensitivity, and then here's the type. You want to say it's mouse movement. The axes, we have two axes, X and Y. This one's X, and mouse Y is the same, except the axis is Y, because the mouse is moving on the XY axis. It has two, it can only move left, right, up, down. Okay, cool. So that's just to show you that. Let's go back to the script. We're putting those values into our vector. And the next thing that we want to do is clamp our y component of local roads. And clamp gives you a little mini definitions. So clamps, math f dot clamp clamps the given value between the given minimum float and maximum float. So returns the given value if it is within the min and maximum range. Okay, cool. And if it's not within that range, it'll just return back the those endpoints. So if y is actually above 80, it'll just return 80. If y is actually below negative 40, it'll return negative 40. I think that's how it works. Yes, and that is how it works. So you can go to the documentation page to learn a little bit more about it. Let's go back. The reason we want to do this is because we don't want it to rotate 360 degrees when we move the mouse up and down. We want to clamp it so it just moves up to the sky and maybe down to the ground, and it doesn't go like between your legs and around your back. Nice, moving on. All right, and now the next thing we want to talk about is quaternion, which is the way that Unity represents rotation. So we want something to rotate. We won't just say, hey, rotate it 30 degrees, or let's look. It won't be like the way that we can change position for the transform by just assigning different values to X, Y, and Z. The way rotations work is with quaternions. So we do things this way, or rotations are represented this way because of the math that goes into actually the rotating things. This is a way that they kind of encapsulate that math, but still make it, I guess, easier for us to use. But it is different than maybe what you expect. So I'll provide a video to talk more about quaternions, but how we'll use them is, let's go back to the cube. Right, so we're doing quaternion.euler, which will, and this creates a quaternion for us. So basically it creates something to represent a rotation. And this rotation will be represented, delivered. Yes, this rotation will be in result of our moving the mouse. So whatever rotation you would expect from the mouse, you would expect to happen from us, doing this with the mouse, that rotation will be created here. And then and you can learn about quaternions a little bit more, or this function, which it says right here, returns a rotation that rotates z degrees around the z-axis, x degrees around the x-axis, y degrees around the y-axis. And let's see. So it's going to rotate around the x-axis this value of degrees, because rotation happens around, so it's rotating around the x-axis, so that's right. What we're saying is the y component of local rotes, we're putting that in for x. Because when we move the mouse up and down, the camera is going to rotate along the x-axis or around the x-axis. And then this one is y-axis, so it's going to rotate this value of degrees around the y-axis. So when we move our mouse left and right, it'll rotate around almost like a pole that's going up and down. I hope that makes sense. Thank you for listening. And lastly, we have quaternion lerp. So lerp you'll give it two rotations. So quaternions, right? You'll give it two quaternions, and it's gonna interpolate between the two, uh, or better word, it's going to give you a value in between the two based off a certain ratio that you give. And this is how you can smoothly go from one rotation to another. So this will calculate all the rotations kind of in between the first one and the from rotation A to rotation B. This will be the ratio. So this is how you go from one rotation to another at a particular ratio or like a particular like a step ratio kind of. Yeah, that's basically it. And it's yeah, I think that's a good description. So yeah, I'll give some more info on these functions, but this is enough for now. So we're going to set this equal to transform dot rotation. Right. And we're saying the rotation A will be transform dot rotation. So the component's actual current rotation. Rotation B will be QT. So this rotation that we just created from our mouse inputs. And then we have time dot delta time because this is going to be something that we want to be dependent on the frame rate. And here's our multiplier or bit dampen. Because it's going to be a real small value, so we just have a multiplier here to make it bigger. Nice. And I think that's it. So let's Control S to save. Let's go. Awesome. Now let's see how it works. So, okay, cool. Okay, cool. So we can move it up and down. We can move it left and right. Nice. So let me know if this works for you. And let's just move around. So one thing about it is, since we're moving our camera around, we're not setting up the player movements in relationship to the camera. The player movements or like when we, click left, right, up, down on the keypad is moving in relationship to the world compass, but not in relationship to the camera. So let's change that real quick. All right, so remember the thing that we want to do is move the camera or to move our player in relationship to the camera. So how we're going to do this, or what does that mean? So before we're moving the player in relationship to the world's compass or the world's yeah, let's say the world's compass or the world's orientation, but we want to move it based off the camera. So before, when we're moving left, we're moving it maybe this way. When we're moving forward, we might be moving it this way, but that's not necessarily what it would look like on the camera. So from the camera perspective, when we move our player to the left, it should go this way. Hit the right key on the keyboard, it should go this way, so on and so on. So in order to do that, we want to do it in relation. We want to move in relationship to the camera, and to do that, would need a little bit extra code. So let's go through it. You can copy it with me. So this is our move player script that we created. So this is the script to move the player. And remember, to get to it, we can go to our assets folder, which you can find it right here. On the left hand side, shows you all the folders. And let's go to scripts, and let's go to move player. That's the one that we created. Okay, cool. And most of this stuff is the same. Here's the stuff that has changed, and then we'll just go through it. So right here is where we're getting the vector. This is like the forward vector of the camera. So we're grabbing camera.main. That just means, hey, main camera. You can hover over it and see the definition. Getting that transform component. And from that component, returning a normalized vector representing the blue axes of the transform in world space. And the blue axes, if we select the camera, the blue axis is going to be the thing that's pointed at, what is it called? Like the lens of the camera. So let's say the lens of the camera, this blue vector, this blue arrow, is pointed directly through the lens, coming out the lens. So this is going to be where the camera is looking at. So when we're grabbing the forward vector, we're grabbing whatever vector that represents this. And it being normalized, what that means is, so a normalized vector is a vector that has a magnitude, aka a length of 1. So like uh, so the actual magnitude of a vector, or you will find the magnitude by doing some math. So you might see some values in the vector. It might add to maybe below 1 or maybe above 1, but the actual magnitude, the actual length, is 1 based off the math you would have to do to find it. So basically, there you go. You just use Pythagorean's theorem. Nice. So that's what it means when it says magnitude or length. But anyway, so that's what a normalized vector is. It's when the magnitude of the vector is 1, aka that is going to give us a we use it as a multiplier, and it's not going to change the uh, magnitude of what we're multiplying it by, but it could have an effect on the direction. Okay, cool. And we do the same thing for camera rights. Let's see what this is. So rights, may not transformed out right, will give us the vector representing the red axis of the transform, aka the vector representing the right side, so coming out of the right side of the camera. So we want to know what is pointed at and then what's to the right of it. And this helps us with our movement. Right here, I'm just setting the y component for these two vectors equal to 0, because we don't want anything to happen on the y-axis. Remember, y is up and down, aka it's up and down this way, so it's, I guess, height, right? Y-axis. So we don't want to have any effect on that, so we're zeroing that out. And then right here is where we calculate uh, our new movement. So we have our horizontal and our vertical um, values from those two axes. So looking at the vertical one, so that's when we move our press up and down on the keypad. When we do that, we want to move forward or backwards. So we're going to multiply that by cam forward to say like when we're moving forward, we want it to move in the direction of cam forward. So we're multiplying it by vertical to give us, and we're calling it forward relative. Then we have another vector, it's called right relative, and we're going to take the cam right vector, which is telling us what is the vector that's coming straight out of the camera on the right side, aka telling us what's right of the camera, and we're going to multiply it by our horizontal floats or input. So this way, when we click the left or right keypad, we click the up and down, we're moving in the direction relative to the camera. Okay. And then we create our move variable. So vector 3, move, and then it's just adding up these two values to create a new vector called move. Awesome. And I'm just logging the delta time, but we don't need to do that. So I'm going to Control S to save. And then right here is the same also. Awesome. If you have any questions on it, let me know. All right. So let's try running it. And okay, I can still move around. And wow. So I'm pressing the forward button, move forward. Let me go towards the house, move towards the house. Let me go to the left. Okay. Now let's try left and right. Move to the left, move to the right. Awesome. So there we go. Now we're moving in direction. Then we have our player in. Awesome.